Question number 14. Percentage of nitrogen in different compounds. Number first is ammonia. Percentage of nitrogen is equal to mass of nitrogen over formula mass of compound into 100. This is a formula to calculate the. Question number 14. Percentage of nitrogen in different compounds. Number 1 is ammonia. Percentage of nitrogen is equal to mass of nitrogen over formula mass of compound into 100. Mass of NH3 is equal to, it is a molar mass. Nitrogen has 14 and hydrogen has the 1 atomic mass. So multiply the 1 with 3 and total mass will be 17 gram per mole. Now divide the mass of nitrogen, which is 14, over total mass of the compound 17 into 100. The percentage of nitrogen will be 82.35. Next, urea, NH2CO NH2. Mass of urea is equal to molar mass. It is a molar mass. 14 plus 2 plus 12. 12 is stands for carbon atomic mass plus 16 plus 14 plus 2. And total molar mass will be 60 gram per mole. Percentage of nitrogen in urea is equal to, here are the 2 nitrogen atoms. So nitrogen's atomic mass is 28 and divided by the 60 into 100. Percentage of nitrogen in urea is 60, 46.67. Next, NH4 twice SO4, ammonium sulfate. Molar mass of the compound is 132 gram per mole and percentage of nitrogen is equal to, total nitrogen are 2, so 28 over 132 into 100. Percentage of nitrogen will be 21.21%. Next compound is ammonium nitrate and molar mass of the compound is 80 gram per mole. Percentage of nitrogen is equal to 28 over 80 into 100 and 35% nitrogen is present in this compound. Now, second part of the question is that calculate the percent of nitrogen and phosphorus. NH4H2PO4 molar mass of compound is equal to 115 gram per mole. Percentage of nitrogen is equal to 14. Here are only one nitrogen atom, so write here 14 and into divided by 115 into 100. 12.17% is nitrogen present in this compound. Now calculate the percentage of phosphorus. Atomic mass of phosphorus is 31 divided by 115 into 100. 26.96% of phosphorus is present in this compound. Next question, NH4 twice HPO4. Molar mass of the compound is 132 gram per mole. Now calculate the percentage of nitrogen. Here are the 2 nitrogen atoms, so 28 divided by 132 into 100, 21.21% nitrogen. And phosphorus, here are only 1 phosphorus and 31 divided by 132 into 100. Answer will be 23.48. Next, NH4 thrice PO4. Calculate the molar mass of that compound, which is 149 gram per mole. Percentage of nitrogen in this compound is 42 over 149 into 100. Here are 3 nitrogen atoms, that's why we put here 42. Percentage of the phosphorus, 31 over 149 into 100, 20.81% phosphorus is present in this compound. Next question is the 15, glucose. Glucose C6H12O6. It is a most important compound in our body. Calculate the percentage of each element. Carbon, percentage of the hydrogen, percentage of oxygen, number of the carbon atom in this compound, number of the hydrogen atom in this compound, and number of the oxygen atom in this compound. What is the formula of this compound? C6H12O6. It is the formula of the glucose. Now, molar mass of the compound is 180 gram per mole. Percentage of the carbon is equal to 72 over 180 into 100. One carbon atom has 12 atomic mass, so multiply it with 6 and total number will be 72. That's why we put here 72. Percentage of hydrogen. Here are the 12 hydrogen atom divided by 180 into 100, and percentage of hydrogen is 6.66%. Like that, percentage of oxygen, 96 over 180 into 100. 96 means there are the 6 oxygen atoms, and multiply the 6 with 16 it is equal to 96. Percentage will be 53.33. Now calculate the number of molecules of the glucose, which is equal to mass over molar mass into Na. This mass is the given, and it is divided by 180 and multiply with Avogadro number. Now number of molecules of the glucose is equal to 0.35 into 10 raised to power 23 molecules. One molecule of glucose contains carbon atom. 6 carbon atom multiplied with this value, and answer will be 2.107 into 10 raised to power 23 atoms. One molecule of the glucose has hydrogen atom 12 into 0.351 into 10 raised to power 23. Answer will be that. These are the hydrogen atom in this compound. One molecule of the glucose has oxygen atom. 6 oxygen atom multiply with the mole numbers, and answer will be that. It is the oxygen atom in the glucose compound. Next question is question number 16. We have to calculate the empirical formula. Percentage of carbon is given, percentage of hydrogen is also given, and percentage of the oxygen is 51.6. It is given value. What is the formula to calculate the empirical formula? Number of gram atoms of element is equal to percentage of element over atomic mass of element. Number of moles of carbon is equal to 38.7. It is the percentage of the carbon atom divided by the 12, which is atomic mass of the carbon atom. 3.225 moles are carbon. Number of the gram atoms of the hydrogen, 97% hydrogen is present, divided by 1.008 atomic mass of the hydrogen, and moles will be 1.6. Similarly, number of gram atoms of the oxygen, 51.6 over 16, and number of moles will be 3.225 moles. Now calculate the atomic ratio. Atomic ratio of element is equal to number of moles of elements divided by smallest number. Atomic ratio of the carbon is equal to 3.225 over 3.225 value. It is a smallest number, that's why we divide the all values by this number. Similarly, atomic ratio of hydrogen is 9.6. These are the number of moles, and divided by this value 3.225, and answer will be 3. Atomic ratio of oxygen 3.225 and divide it by this number. It is smallest number. We divide the three values by the same smallest number. Answer will be 1. So empirical formula is equal to CH3O. This ratio tell us about, here are the 1 carbon atom, 3 hydrogen atom, and 1 oxygen atom. CH3O. This is the empirical formula of the compound.